Hi, Kurt.
Hi.
You want to talk about AI stuff?
Yes, always. That's
Awesome.
my favorite topic is stuff of some kind.
Stuff of AI. Yeah. So as we talked about several weeks ago, we don't have human customers anymore. They're all robots, right?
Yep.
And so people are starting to use the platform a little bit different. For those that can't detect sarcasm, that was sarcasm, but only a little bit. I think it'd be interesting to see how these customers are using the platform and why they're starting to use this. And I
Yep.
already said before recording that I didn't actually want this to sound like an ad, but
No.
whatever. Let's get into it. So what are you
Uh
seeing?
yeah. Actually, what we maybe should start with is why we built the wrong platform.
Yeah.
Back in the early 2022s, what was
Hmm.
it we were doing? We were using Nomad. We were basically like trying to
Hmm.
get what I'd call sandboxes. We were trying to get like little pieces
Hmm.
of code running on behalf of customers. And what they all needed was something Heroku-y. They
Yes.
needed something where they could just take their app and they could run it, and then we could like get VMs running for them in different places. We could start and stop them. One of the things they needed that is correct is a lot of those people were really hypersensitive about not paying for stuff they weren't using,
Yeah.
because people building side projects don't want to be paying for memory that
Yep.
they aren't actively using. And so most of what made the machines product was sort of it was. We have a whole blog post about how we do orchestration, but the idea here is that we didn't use Kubernetes. We were using Nomad because it was lighter weight than Kubernetes. We could fork it, but it still wasn't correct for us. And we had reasons for building machines like we did, and some of them were really, really useful now. But
Hmm.
generally, what we were trying to do was take, I don't know, like 100,000 paying customers that each had their own app, sort of like running 100,000 unique apps for people. They generally wanted to run multiple instances. They wanted to scale out a lot and use the database. They would maybe want to run in multiple regions. But a lot of the magic was like, I have 500 instances of my Phoenix or Laravel or JavaScript app running, and I just want the people in Sydney to get the one in Sydney. And then if it gets to be too many in Sydney, I want them to be routed somewhere else. There's like a lot of cool stuff in there that we needed to support this platform as a service style customer. We decided to build machines on the premise that like one of the philosophies I felt like is if we're building cloud infrastructure, we should make it as lightweight of abstraction as possible and let people get out of our design decisions and use really low level stuff. And so machines were like, well, what we need is this thing to launch VMs, so why don't we just ship that as an API and then build everything
Yep.
on top of it? Which I really like. I think that it sounds really good on paper. It doesn't always pay off, but in this case, it was a fun thing to do. And then at the same time, we were like, clearly the world needs like safe sandboxes to run code you don't trust in, which is effectively the problem we were solving. Is we have all these people coming and signing up and running apps. We don't trust their code. They're up to no good, probably, or it's just gonna go wrong. And so a lot of the job was like make sure that we could safely run arbitrary user code that tended to be kind of a fat app with a lot of dependencies, and like a million users would use it, not just one. Um, and then that it sort of sat because it did what we needed, but like a lot of people wanted something like this, but they all wanted a different type of platform. So it ended up everyone that was a machines customer between 2022 and early 2025 wanted like they're like the Venn diagram of things they needed actually had like this much overlap. Like they all needed that VM to run, but everything else, like the people needed UDP, they needed they needed GPUs, they needed all of these things, and like no two customers had much overlap, which is a death to a startup. We can't possibly build all those things. And so we made a
Mm-hmm.
couple runs at these things being useful, but it always sat there thinking, hey, this is a really interesting product without like a strong single use case, which is like product market fit 101 for
Yeah.
startups, I think. And then I don't know, like the AI stuff happened, and we first tried to like, oh, cool, everyone wants to do inference, let's do GPUs. GPU machines are great, not what people wanted. No dev wants to pay NVIDIA enterprise pricing to run a GPU on the cloud. It's just too expensive for what they want to be doing. Um, and so, but still the machines persisted. And back in, I want to say like September, we started seeing some surprisingly large users of machines doing very similar things. And effectively, they were all building agents. And what they needed was actually, it's hard to do what they need to on the platform. We've been making it better. But what they needed was where before we needed 100,000 devs to run their apps for their 100,000 users. So like they deploy an app and then 100,000 people use that app before it ever changes again. All these people need like a million new devs to deploy a piece of code that may only run once, that needs to be stopped most of the time, that might need to come back in a few weeks. They never want two instances of it. They never want to scale these things out. It's entirely one thing. And then the big, huge weirdo thing is these all want state. So they all want a place to stick data. Um, and like even the big leap for me was when I realized that like they're actually treating code as state. And so what they do is they launch a sandbox, they make it how they want it, they keep putting iterations of code in there. It's no longer like an immutable sandbox that you launch a million of the same instances of. It's a starting point for something that then becomes very unique and does exactly
Yeah.
one thing, hopefully for exactly one human. And it goes away and may never be used again. But if it is used again, it should come back again. The interesting problem is that in a world where if you can make it cheap enough, people are happy to have two available VMs for their app. You do things differently than if people only want one. So if you want 100% availability in 2023, what you do is you make it so it's so cheap to have two VMs that people are just happy to run two VMs. And then when you
Right.
when you need to make a request and one doesn't start, you just start the other one. It's just not a huge deal.
Yes.
And in 2025, people don't want two VMs and they do want state. And so all of a sudden, like a lot of the design choices we made to keep things simple and predictable are actually like rearing their ugly head for people who
Mm-hmm.
what they have is a machine that runs that they can't get to come back when the user next wants to use it in 3 weeks because it's somewhere that's full and we can't start it. And writing all the code to manage that is a huge pain in the butt for them. And then the other one is that they want to create a million of these things instead of just 100,000, and they want to do it when people click a button. And so what they want is to go from zero to a running machine um, when a user wants it, like while they're waiting for it.
Mm-hmm.
And it mostly works that way. The problem is it doesn't work that way enough. And so we were in 2023, this was fine. If a random machine took 7 minutes to create, someone's like background CI deploy was slower and they really didn't care all that much. In 2025, a random machine takes 7 minutes to create. What probably happens is the user clicks the button 37 more times, and all of a sudden you have a lot of slow to create machines trying to come up, and
Yeah.
then you run into infrastructure bottlenecks. So there's a bit of that, like a huge mismatch there. And so we ended up with this machines product that has really good primitives for solving a lot of really interesting problems um, that is hard to use for this. And so the effort now is to like make it work really well for one exact use case that it seems like everyone has, which I think is really cool.
Yes.
Um,
Yeah, and
which
I
is
think, well, in our defense, 2023 was the year that everything changed. Or like really
yeah,
we
yeah,
saw it
right.
just right. That's like, well, I don't I don't know if we could have foreseen that
No,
exactly, but yeah.
in our defense, we were playing in the same arena. Like we were like
Yeah.
not far off, but it wasn't because we thought LLM things were going to happen. I want to be like, yeah, we knew this was going to go this way, but the reality is like we knew that there were reasons this stuff was valuable, and this thing just so happens to be a valuable way to take advantage of it. But
Yeah.
yeah, but everything's changed. It's bizarre. I still don't get it entirely. It's all very different the way things be.
Right. So what
Wait, we
I
did get one
oh,
thing correct,
okay,
which is
what'd we get?
volume forks. So like volumes are block
Mm.
devices that are fast, and you can instantaneously fork one and start using a new copy of it in a way that like everything LLM based, every agent on the planet it can take advantage of state that's easy to fork. It's like one of the most powerful things you can give one of these LLM loops.
It's really strange to me realize like not realizing, but seeing that state is suddenly so important when I feel like the I was raised on the oh my god, now I'm blanking on the term. The tenets of Heroku. The
Oh,
12
the
factor.
12 factor, yeah.
I was raised and not that like that's like we're not throwing that out necessarily, but so much of what was beaten into me is like pretend it is all ephemeral. State is your enemy. If you want to store anything, it needs to go in a database. Nothing should be stateful. And I think that there's value in that to some degree, but all of a sudden, like with the type of things that we're talking about with running agents and running LLM code, state matters. It does matter. Oops, it matters now.
Here's my theory, which is really insane, which is that when you are building software for another human, What you need to do is you need to find the version of that software that's useful for the big enough group of humans that might take advantage of it. And by definition, it's not going to do what all of them need. It's going to do a little bit that hopefully all of them need. And then you're going to give the same thing to a million people and be very excited about this. And so all of Heroku 12 Factor was like, we have a relational database with one schema. And all we need to do is accept requests and conform everything to this one schema and then get our customers to come. And hopefully there's enough of them to build like a Trello or whatever that they can all work in this one schema and this one UX. And the giant difference, I think, now is that the like UX, like a human interface for computers, reduces to like how well can you tell the computer what you want to have happen and get a good result. And so all of those constraints with code and databases were us limiting what could happen so the people coming in could get some success out of it by not going too ham and off the we can't say off the reservation. I don't know what that was from. But
Off the
you know
rails.
those cool off the rails. There we go. Yeah, to go off half cocked. That's the other fun one.
Yes.
That's a little bit violent. Yes. Um, they and so like all of software has always been like build something and then hope that 100 people use it to make it worth spending all that time and energy on. And now all of a sudden we have these things that can write not very good, but they can write exactly one piece of code for exactly one person, and that one person can get some value out of it. And so, like, obviously, the infrastructure for what was here 4 years ago is incorrect for what people are doing now. But for me, the most exciting thing is we get to take away a lot of machines features and suddenly have something really valuable by doing like three exact things well, and we don't have to do anything else well. It's just three things, and then we will be fortunate that we were kind of fiddling with this stuff for 3 or 4 years at this point. So everybody has, and this is true. This is where the agents where it gets really weird because everybody who says agent has a specific idea of what an agent is.
Mm-hmm.
And every time I
What's an
talk to
agent?
companies about agents, it's like not quite the same, but it broadly similar. And so we've got companies that are doing like we've got a big one that uses us for preview servers. So they have a code editor running stuff, and what they do is their code gets into a Fly machine, and then is then served to their user as like here's what your app looks like right now while you're in
Mm-hmm.
development. We've got people where it's like a whole IDE where they're running code server, installing a tremendous number of dependencies. Um, and their users are again making HTTP requests into this thing, but what they're doing is they're driving an IDE. They're not just using an app that is half in development. And then we've got people running like MCP servers where same general thing. There's like HP coming into the compute and it does some stuff. And the only real difference between all of these is the size of like how chunky the compute is they're running. Like the IDEs need a lot of RAM, the dev server needs a medium amount of RAM, and then MCP servers tend to not need very much at all. But
Yeah.
like what all of them actually need is state that sticks around, an endpoint to connect into these things, and in a way for the compute to come and go like as necessary. It's like truly disposable compute. All that matters for like a new app is like the name, like the URL that gets to it, and then the data that applies to it.
Mm-hmm.
And in most cases, the data is actually inclusive of code. Like code is actually state in those because all of these things end up mutating code repeatedly, in addition to
Mm-hmm.
like writing things to a SQLite or making API calls or putting files on disks or object storage or any of those things. So there's precisely three things. It's a
Mm-hmm.
URL, it's a place to cram a bunch of data, and then it's a way to get compute running against this as fast as possible,
Yeah.
effectively. And like
Yeah.
nothing else matters. And they need to be able to do it for a million people, not a
Yeah. I
hundred
feel like
or a thousand or 100,000.
that's the tricky part, right? Is
Yeah.
doing it and doing it quickly.
Yeah. Doing it quickly, doing it reliably. I think the big thing for us is our machines infrastructure is sort of designed to fail in predictable ways, and then you're expected to
Mm-hmm.
kind of accommodate that problem and do something else. And what these need is the next million times they click this button for it to just work. And the 99th percentile of how fast it works needs to be pretty good. The 1th percentile can be slow. They're not too worried about it as long as it still works. It's like
Yeah.
it's a slightly different heuristic than what people cared about before.
Can you kind of already touched on this. I don't know if there's more to expand on, but describe some of the a little more detail the types of ways that people are using LLMs to run AI code because
Yeah.
there's a What are we talking
A
about? Is
lot.
that all? Would you consider that all agentic work? I hate the word agentic. I can't get used to it, uh, uh, but like, what would you? I feel like there's two questions here. Is what would you consider an AI agent and agentic workflows, and then what are you seeing our customers do? Like,
Right.
is this a useful term to even communicate with them on?
I I think infrastructure for agents is a useful thing to think about. What I've been surprised about, and I've talked to them, there are people who treat the word agent as what I call the LLM loop, where they're getting ChatGPT or whatever, Claude, to like make predictions for them. So they run this loop of like making requests to that API, doing stuff with it, making requests to that API. And for some people,
Yeah,
like that is the agent bit. And then for other people, it's like something that those things control separately that just happens to run in the background. For some people, it's like an agent is the thing that does
like
things when I'm not
function
there.
calling.
Yeah, some kind of function calling. I don't. I feel like the word agent's kind of interesting though, because like to me, an agent is something that's doing something on my behalf, and it's a not.
Yeah,
It's not. It's not. It's not. All of those things are agents in their own ways, and even the weird difference between something that's like doing the LLM loop and something that's just doing MCP server protocol calls is that it's really there's not that big a difference. They're basically doing the same stuff.
no, they're both iterating.
Um,
Yeah, they
yeah.
both. I just was learning about React, not React JS, but like Reasoning Act. Um, it was actually part of the prompt engineering white paper I learned. But it's like they use this to describe that LLM loop of like create a plan, try and do the thing. What was the output?
Yeah.
Create a new plan, rinse and
Yep.
repeat. And that's like that's MCP does that too, right? Like it's
Yes.
whether or not your MCP just says like, do you want that loop to include? Do you want to loop in
Calls to other
another
things. Yeah.
external an external thing, right? That's the
Yeah.
only difference. But it's
I,
all that
I
rinse
think
and
the
repeat thing.
I think the purists are probably not calling the tools agents, but to me they're agents because like the
Mm,
very first thing I built with any of this stuff was a Spotify agent that would like watch my library and make me an Apple Music video playlist based on my favorites. And to me it's like, well, that's
mm-hmm.
running somewhere doing work on my behalf.
Yeah,
Generally, it was built by an LLM, and I can control it with an LLM because I can just tell the LLM what I want, and it can make a tool
yeah.
call and do this thing. But it's not really doing that whole loop, and I'm
Mm-hmm.
fine with that. I don't think we need to be too gate. We do love being gatekeepy, but our purposes, the more we can call agents, the more we can sell to people. So we should definitely call everything an agent. Okay, the infrastructure for agents, though, I think is
Mm-hmm.
what's most interesting to me because all of these things need, and this is where the code as state gets fascinating because like the LLM is probably writing new code when
Mm.
it's running in its little loop and then trying to run it either through a tool or by itself. But even when it's calling tools, it could actually be sending patches to code. This is actually more common than I expected. Is there's a lot of people doing one thing over here in an LLM and they have effectively a tool over here and they're sending changes over to that tool that then updates its code state and runs stuff locally. But the most fascinating thing to me has been well, there's a lot of most fascinating. There's seven most fascinating things to me, and I'm going to enumerate two of them. But the
Mm-hmm.
one is that code is now state in like the most pure way you can imagine. It is very, very fungible. That's changing. It's dangerous. Like the tools you need to manage state that changes is like far more important than they used to be right now. And then the other one is that everything I've run into ends up benefiting from like a local SQLite or object storage. It's like all of these things actually benefit from having a place to write data for itself to the point where I have like extreme views on like what kind of APIs people like Spotify should be delivering to me now. But like all these things need the same sandboxes and they all need the same, they need to manage the code as state. Stuff we don't solve for people yet that they try to solve is like they need to do things like checkpoints when they change code. And it's best even if you can checkpoint all the state of the file system when you're doing the checkpoint so you can really revert back to something else. And you'll be able to fork these things so they can try new things in isolation, which we can do because
Yeah.
of disks.
Um,
Um,
where do you feel like so I haven't latched on to browser-based vibe coding type stuff. I do my vibe coding with cursor and stuff like that, but
yeah,
that's all local. And I have Git, and I know how to use Git, and I know how to,
yeah,
it's great. I've got my cozy little environment that I'm used to using, but there are these other tools that people are coming out with, and
like
we're
us.
talking, yeah, and when it comes to managing state and being able to track that, do you see people handling things differently? Because the need for version control looks a little bit different than for
It
some of these
does.
platforms. Like, depending on who you're catering to. If you're a developer, like, yeah, just use Git. Okay. But like, there's sort of middle grounds, and
Yeah.
where do you like, is there
Yeah.
value in not forcing people to like create a commit, create a commit, create a
Oh
commit
yeah.
every single time?
Well, Cursor does a lot of checkpoint stuff that I don't even fully understand and I don't get to use very well because I don't get it. I don't know how to make Cursor undo things that it's just messed up reliably. It's just like I don't understand what Cursor's doing for me, but I know they've done a tremendous amount of work to try and make these things happen. Um, my feeling is, and it Git's an interesting one because Git is very self-contained. Git assumes everything it should know about is already in Git. Git doesn't really care about like a, okay, so like in an ideal world, when I'm making changes to a project and then running them, and then I want to roll that stuff back, my whole disk should actually go back if I want it to. Like everything that it might have touched on the file system, I probably want to undo
Yeah.
just to try things out sometimes.
Not
And so
just this
Git
little
doesn't,
pocket. Yeah,
yeah,
exactly.
Git's not useful for that. And Git commits are not heavy on disk, but they're heavy UX, where it's like you have to make a whole choice to commit stuff instead of um, have it be incremental. And so Git's a great tool. Probably a lot of the stuff's going to be built on it. But yeah, there's something different here that doesn't, I don't think everyone's figured out or anyone's figured out yet, which is like you sometimes make 6-line changes and want to roll back. Sometimes this maybe gets back to how you're telling the computer to do things. Because usually what goes wrong for me is I tell the cursor or the computer I want something to happen. I kind of can detect that it's successfully done this or it hasn't. I can
Mm.
tell it, no, this is actually what I wanted to see. And there's a point in my brain where it's like, this is progress and it's not doing something I want. Let's move on to the next thing. And then when this goes wrong, what normally happens is it goes and breaks a bunch of previous stuff while it's trying to make the next thing work, which
Yeah.
sounds like it should be a Git commit to me,
I know.
but it's
I've run
not.
into that.
It's not Phoenix. So Chris is doing on Phoenix.new is he's trying to, I think he's making some guesses about when to do those commits on your behalf.
Mm.
So there's actually a Git history that looks like good chunks of work that I think makes a lot of sense. But it's, I think in the reality is none of us are going to look at Git for these things. What we're going to do is we're going to tell the agent what we want to see. We're going to tell the agent how we're going to know if it works, and then we're going to let it go off and do its thing, and then come back and tell us if it happened or not. And then we're going to
Right.
decide if we keep that work, basically.
I think
Um,
so. It's, you know what? I would say that's not actually that dramatically different from when you're just doing it the old-fashioned way. Because no one's making a commit for every little file that they've changed, or at least I don't. But so
No, right. What you do is you send some junior dev off and they do a pull request and then you bike shed it repeatedly until it's what
yeah,
you want in
yeah,
GitHub. But yeah, it's basically like these are things that but the difference here is that I can get this thing to do 50 of these at a time. And so that it's still harder than like Git PRs. It's just not very the way we do all these things with humans and the way that we let these computers work. But even your
hmm,
cursor environment, I think things only run locally because it's easier right now, and there's no way that's going to stick. Like a cursor should arguably be operating on a virtual version, like some kind of sandbox based on your environment.
yeah,
That's that really you can dispose of or you can constrain in some way. But
sure,
also, is that there's like the whole security take on here. But really, these
yeah,
agents all work better with constraints. If you let them
yeah,
have less things they can fiddle with, they tend to do better work, just like humans.
yeah, exactly. This is a weird comparison, but it's almost like I've heard comparing console games to PC games is very different beasts, because with a PC, you don't know what you're gonna get. You don't know what specs you're
Right.
getting. Whereas like a
Yeah.
PS5 is, this is, we have this much memory,
Yes.
this is what you're working with, blah. So
These are
yeah,
the
having any
buttons you
kind
have
of,
access to. Yeah.
exactly. Yeah, so having a
Yeah.
clear sandbox environment where you know what you got, you know what you don't got,
Yeah.
it's easy to understand.
Yeah.
It's easy to like debug things and figure out what's going
Right.
wrong because you have the full picture. And that, I do
Yes.
think that what's cool about with something like a fly machine is that we are basically giving it the keys to the castle, because you have root access, right? But it's okay because it's a root access of this thing that we've put in a little box, and it's
Right.
fine. It's fine if you mess up,
Yes.
right? So, but it has full
That's
control, so it has full visibility.
right. But you give it exactly what it needs to start with, and then it has a lot of power to
Yeah.
go do things.
Yeah.
But it's still like you're not giving it everything on your local disk because that's a lot. Even
No.
Cursor doesn't do that.
No.
Cursor is happy to go outside of the project directory I'm in, which freaks me out. I don't really love that it like tried to edit my Etsy host file and read my SSH keys, but
That is a
it's
little
still
concerning.
trying to stay constrained.
I never fully understand where it's operating. I'm like, where are you?
Mm-hmm.
Where are you sitting? What
Mm-hmm.
directory? I'm assuming you're in the same directory as me, but I
Yes.
don't know. Someone's gonna be able to tell me in the comment section. Whatever.
No, you don't know. I think, well, because the problem is these things are like really like hyperactive 16-year-olds
Yeah,
that can work way faster. It's like you're not going to let my child on your computer do whatever they want.
I
And
know.
if my child can operate 75 times faster over the course of a day, it's especially scary. They're going to
Yeah.
go riffling around through things that
Yep.
I don't want them to.
Okay, so we know where fly machines are lacking, and we also know where fly machines heck and rule for this kind of stuff. Where
Right.
are we going with this? What's the future, Kurt?
Yeah. The well, one, I'm excited because it's fun to actually work on fly machines with intent instead of it just being this cool thing that's out there that like we haven't figured out how to apply yet. But there's two things in parallel. One is that the fly machines product and API aren't perfect matches for what people are trying to do. People have to write a bunch of code to use these things well.
Hmm.
Where there's some of that code is stuff like checkpoints and rollbacks of state, a lot of stuff that is pretty unique to this specific thing. Some of it is that they have to work around some of our limitations for like machine creates being kind of heavy or starts failing sometimes. And so those
Mm-hmm.
that's the two things that's like the most notable things are machine creates are about to not be heavy. The idea here is that you should be able to go create a new machine from scratch. And sure, maybe it's
Mm-hmm.
not very fast, but it works consistently. And when I say not very fast, I mean like 5 seconds, not 100 milliseconds, not like
Uh-huh.
12 minutes, but
Mm-hmm.
consistently. And it will consistently work, and you can consistently count on a new created machine for your next million users to come up if you're giving us enough money. That's the other thing is like given enough capacity purchased.
Sure.
And then the other one is, which turns out to not be very much money relative to what other people
Mm-hmm.
charge for similar stuff. But then the other one is that we're actually trying to solve a lot of these state problems. So what is different than when we launched machines is we now have Tigris buckets available to us. And we also now have a much better, it's called the init, we call it pilot, but we have a much more powerful
Mm-hmm.
environment that runs inside the machines that we can do a lot of interesting stuff with. And so, like, I don't know how this is going to get shipped yet, but one example of what might happen here is we have a variant of a sandbox we can give someone that has like a ready to go SQLite with Lightstream, just ready to go, backed up. It has a file system you can use, and then it has a basically an MCP server that accepts code or a Git server that accepts pushes. And each time you put something on the thing, it will actually snapshot its own state and then allow you to roll back, or it'll even let you fork off to another machine to do a thing. And so the idea here is it is actually instead of a build a Docker image and deploy, you come up with this environment and start pushing code into it,
Mm-hmm.
and it becomes a pretty powerful way to like do these agent code things and checkpoint, restore, and fork, and all these things. That's the fun one. They're all fun, but the machines can be more reliable for what it's doing. And then there's a new style layer here that does a lot more for these specific types of products.
Anything else that you want to mention that I didn't ask questions about?
We can actually talk about why images are so bad for these someday. That could be a whole other thing. I've
Oh
learned a lot
man,
about Docker images and why we
could
shouldn't be using them for some things. So
okay. So we've already I mean a bunch of people on the internet got real angry at me for saying that containers weren't that good. I don't know if you're talking about Docker specifically or containers or where is
Mainly the
this
images,
the
Docker
images? Okay.
images.
Oh,
Docker
images,
itself,
not
yeah,
the
we'll see.
containers.
Yeah,
Oh, this is a.
yeah,
I feel like we got to put a pin in
whole new
this one.
fun thing.
This
Yeah, we
feels
do.
like a.
And get more people mad.
Okay.
How dare you be female and talk about these things? You're definitely gonna get
Yes.
that reaction.
Yeah. There's a lot of that. Yeah. Yeah. People don't like it when I talk about containers, apparently. So
No,
that's
well, they're all
why.
dumb, so they'll get
Yeah.
over it, or they won't. We just call them
It's
dumb.
okay. That's okay. Okay. Cool. Well, I think this is a good wrapping up point, and
Good deal.
I'll spare my earbuds, but this is
Yes.
exciting, and we're excited about all the cool things people are building on the platform. But
reasonably good chance we can actually show you a demo of the checkpoint stuff in the
Ooh.
next couple weeks. So
Oh,
we can go look at
exciting.
that. Yeah, right.
Me or the people?
You, and then you can
Okay.
show the people.
Okay, I will show
It'll be great.
people. I will show you. Where's the
Yes,
camera that I'm using?
exactly.
I'll tell you. I'll show
Oh,
you.
the
Yeah.
people over there. Yeah, I don't have
I
to. I
don't
don't
know
want to.
which
People
camera
don't
I'm
want to look at.
using. I haven't decided.
Fair. Yeah.
Awesome. Well, okay. Well, thanks so
Great.
much for chatting with me, Kurt. I'll talk to you later.
Thank you. All right.
Bye.
Bye.